Hello boys and girls. In this video I want to look at the algorithmic ideas behind a voting mechanism related to social networks and token votes for dollars, and there's like different token implemented in this system, and there's an interplay which makes the whole thing very like complicated and volatile, but there are some interesting ideas there. It immediately piqued my interest, and I want to explain this. And for those who are like participating in this YAPS activity, in the video I want to explain the relationship of voting power between the Genesis NFT and the sKAITO if you stake them. The TLDR is that the math plays out in a way it's designed so that you basically always get the same voting power for your buck. And we will explain how this comes about, and also explain this sort of volatility in voting power that is shown in these on the website. I'm going to explain this formula, and I find this quite interesting. For those people who are following my channel since many years, there was a time, what is this? There was a time when I, like 7 years ago, I can't believe it, over 7 years ago, when I did a lot on voting per se. The mathematical theory of voting is quite crazy. And crypto rewards, computation, this kind of thing. So this is very in line with stuff I did in the past. And with that said, let me give you 1 minute to explain this sort of the background. Okay, so there's this company, I think it's 3 years old, called sKAITO, which you can pay for getting valid, good marketing information. So they basically scour the internet and do sentiment analysis and who talks about what on the internet, in particular here on Twitter, but I guess also elsewhere. And you can pay them like $1,000 a month or so, I heard, to find the most important people talking about the subject that you want to sell something in. And then you can find the people who make contracts or make decisions based on what people talk about. It's a sort of marketing thing. It reminds me a little bit of Palantir insofar as they employ machine learning for this kind of stuff. So this in general pretty cool. And then they have this sort of side hustle, which is called YAPS, where essentially they provide a voting platform for crypto projects, and they involve their own token. And I think it's fairly complicated because they give people who talk about stuff about crypto on Twitter, let's say, voting power to vote for projects, and then they tell the projects, hey, these and these people have voted for you, or these are these people, they are the top talkers about your project, and then please go ahead and reward them for that. And so there's like a complicated like economics behind it. But in particular, there initially you have this situation where if people talk about certain things, they scan this, and then they assign them the so-called YAPS. This is sort of their voting currency. In this video, I will just talk about like voting power, right? So the abstract from the YAPS. But basically, if you talk about stuff, you get voting power assigned to you, and you can use it then to vote. Okay, so there's this part. And then there is the part where they have some token. They have one so-called Genesis NFT, then a non-fungible token, of which there are only 1,500. And then they assign also voting power to just the holder, just the people who stake these NFTs, also get voting power. So you do not have to just be like a famous person or like a smart talking person on X, but you can also basically buy into votes. There's this one token which has a supply of just 1,500, and then there's another token which has a supply of 250 million. And if you have that and stake it as well, you also get voting power. So there's two mechanisms of buying voting power. And I saw this, and the first question I had is like, is there some arbitrage? Like, how do the voting powers of these relate, and how do these relate to the price of these tokens? And to cut it short, the answer is that the math plays out that the that you always get the same voting power for your buck, which is quite interesting. On the other hand, as noted, the math is so complicated. I mean, it's just simple arithmetic, but nonetheless, the dependencies come about in a way that these numbers are extremely volatile just from how this is implemented. So I have seen this, the voting power of an NFT, I have seen it down at around 20,000 votes, holder votes power. I have seen it up at 120,000. And this just within 1 week, so it's like going up and down like 5x or whatever. And similarly with this, like what the voting power per token, per fungible token, is also like now it's very far down at 6.5. I've seen it up at basically here they set a limit that it can go up to 40 in principle. And this is interesting because the value basically prices the natural talking voting power, right? If you just talk, if you do some effort and talk about a project, you get voting power assigned, but you can also buy it. And so this is interesting how this like relate to each other. There's these three components. Okay, so here on the website you have the math that they implement. They also have FAQ, which I'm very glad for. There's a lot of nice pages, but it's also on the other hand quite messy and sometimes ambiguous. So I have a little bit of a criticism of that as well. But overall, it's a very interesting project or company really. And so you have a formula. We will explain this formula for both of these tokens. They're basically the same formula with different stats, and explain how they relate to each other. Okay, so let's get into it. On the one hand, we have the voting power assigned to people who just talk. And this is assigned on a continuous basis. So, you know, every morning people wake up and the algorithm judged, oh, you have had this many interesting posts and replies about the topic. You get assigned this and that yaps. This is this voting currency, which translates to the voting power. Here I choose the unit V for votes. I write M for million, just that I don't have to write these numbers, and I plug in some example numbers which are close to what they currently are today. So currently, I mean, you can go back and also see this here. There are in total 40 million voting power assigned just from yapping, just from talking on X. Okay, so the voting power assigned on X is 40 million votes. And the one decision they make in the implementation is, I think they say this also here, the sum of yapper votes in relation to the sum of holder votes is 1-to-1. So there's a 50-50 split on where the voting power for these projects come from. And by the way, I got interested initially about that because you know, there are some airdrops for this project Somnia. Shout out in this moment here, and that's why I even got into looking at this company. And so while these yapper votes grow with time, and also there's like voting periods, and so this break down again, the votes assigned by these two different tokens in sum is also always the same as this number. So at the moment it is at 40 million votes, which means also the token have 40 million votes. And then the question is, what system do they use to split between with the one token and the other? Okay, so let's talk about stats for the fungible token. There's 1 billion, but in an actual circulation, there's only 1/4 of that, so 250 million. The current price of the token is $2.3, and so that makes for a circulating supply, a market cap of the circulating supply of about $500 million. However, you know, to vote you have to stake, so only a certain fraction of what is actually out there on the market is actually used to vote. And by the way, I do not know if in the formulas they count everything that's staked or only those staked ones that are actually currently voting, but it doesn't really matter to this video, but this is something I'm not 100% sure about. Okay, so if you go on this site, you see numbers. So this is the formula. We will get to it in a second. But there's 40 or 40.7 million YEPA votes, and then there is a staked sKAITO amount of, here at the moment, 4.4. When I wrote down the numbers on my sheet, it was 4.1 a few hours ago. So you see how this goes up. So this is the one number, and here's then a ratio of market caps, okay? But the staked sKAITO on these slides we take to be 4.1 million, right? We saw they are just at 4.4 million. Okay, and so it means of all the sKAITO that are out there, only 1.6% are actually currently staked or voting. And the market cap, which plays a role in the formula of the staked sKAITO, is the number of staked sKAITO times the price of $2.3. And so this means that $9.2 million are currently staked and voting with this sKAITO. And the NFT calculations are similar, but look a little bit different in the number. So there's only, not in the millions, but only 1,500 supply, which is even for NFTs very little supply. The price is currently at 5,700. So if you multiply those, that means $8.55 market cap of for the whole NFT, but out there staked, and you see this here, is only like currently 236. When I wrote this down, it was 230. So this is the number of staked ones, right? 230 out of 1,500 are actually voting, meaning 15%. This is more than with the fungible token, are actually staked and voting. And the market cap of these staked and voting token only come out to $1.3 million. So if you compare, this is like a little bit more than 1/10 there. Okay, and so now to the model, right? The model is directly read off from the FAQ or these formulas that you see on the website. So firstly, as they say here, I think I pointed it out already, right? The sum of all the YEPA votes is always in the same relation, is always in the same number as the sum of votes on social media. So the voting power of the fungible token plus the voting power of the non-fungible token always equals the voting power of on X, right? Currently like 40 million. This is the first decision that they make. I already talked about that. And then by how they implement it here, right? By this formula here with this ratio of market caps, what you also have is that the ratio of voting powers, if you divide both formulas basically by each other, are always equal to the ratio of the market caps, like in dollar terms, that these two different tokens currently have, right? The ratio of the voting power of the NFT versus the fungible token is the same as, however, the whole lump sums of all the dollar worth of the stake token is. Okay, so if you want to implement this these two conditions, then it's very easy to do the math. There's some linear relation. You find that these are fulfilled by this formula here. The voting power of either the fungible or non-fungible, this I denote with this I, can be either of those, is a fraction of the Twitter voting power, and it is given by this factor. The voting power of I is given by the market cap of I, and then to make these conditions work out, you have to normalize it by the sum of the market cap, right? If you use this and you can plug this into these two formulas, you will see that both conditions are fulfilled. If you sum up VK and VN, then by this normalization here through the sum, you exactly get this is VK, And also if you compute the ratio of these two, then because, and this is a crucial point here, these first blocks here, they are actually the same for both. You see that the ratios of the V's is the ratios of the C's. Okay, so here this formula is, however, on the website expressed a little different because they want to state how much voting power you have per token, right? I guess for people to do this sort of calculations, even if you will see it's so volatile that there's no real use of that. So the voting power per token, if you want to know, how much voting power is my token that I just bought worth, you divide by S is what I call the number of staked tokens, right? The voting power of all of your, you compute the voting power, let's say, of the NFT by taking the voting power of all NFTs and dividing it by the sum, the number of NFTs that are out there. In this case, 230. And what you do, you do the calculation. You see that since we set the market cap is the number of staked tokens times the price, you find that the voting power of per one token is this constant factor times the price. And here I refer back to the website. So in the website, what they do is they express the price as the market cap divided by the number. So this formula, the Yappa votes divided by the number times the ratio of sums. This is exactly the formula you see displayed here. This is actually the formula in this more or less helpful presentation. And what is interesting about all the math, or what this gets at, is the fact that you might now ask, okay, what is actually better to buy, the NFT or the fungible token? And so if you compute the ratio of the voting power of the NFT versus the voting power of the fungible token, you find, just by how this is designed, that is exactly the ratio of the prices, right? So this is just plugging in the numbers. And that means that if, for example, currently the NFT, which costs 5,700, it is 2,478 times more expensive than one of the fungible tokens, right? But because how the math checks out, this factor of roughly 2,500, that the NFT, the big NFT, costs more than the small fungible token. This is exactly also the factor by which the NFT has more voting power than just a small token. And this means basically that it does not matter what you buy, you always get the same voting power per dollar, right? Because the NFT is more costly but has more voting power, and this is designed exactly in the way that the voting power and the dollar price are perfectly correlated. And so I write here, you get basically voting power per buck with this model. And so this constant factor here that we have here in this formula is Vx divided by the sum of the market caps. If we plugged it in, for example, here for the current values, so 40 million votes divided by this roughly $10 million market cap, this is the sum, then you get this number 3.797 votes per dollar, right? And this is basically the crucial number that you buy. If you spend $1, you get 3.8 roughly voting power. And this is relevant because the yapping also gives you voting power. So if you chat about a project on X and they assigned you a voting power, I think for one yap you have 100 voting power. So this is the relation, but this is not relevant for this video. But it basically tells you how much dollars you have to spend for one yap. So there's a correlation. Then basically it's pricing essentially the effort of tweeting. Like if one yap is you sitting on an X, I don't know, 1.5 hours longer than you would want, and you consider it sort of speak work, then you could say, oh, in this time for just, I don't know, $30, I could have bought the same voting power, and to the extent that you want the voting power. Then you see how this is priced based on how much total X voting power there is and what the market cap is. All in all, as I said, the thing, however, with this model is that there are several variables, the price and then the number of votes out there, and they have these voting periods that makes this fairly complex. And these go up and down because there are so many variables multiplied together, which makes sort of these numbers a little bit strange. Really, what is of interest is who wins in this race. But because these numbers change so much, stating the if I have one NFT and there's this voting power, but then a lot of things happen. The price of the other token goes up and down, and all these factors change around. Then these numbers will change. What's really interesting is that this project sKAITO, I don't know how to pronounce it. Succinct, okay, is a little bit ahead of the project Somnia, right? So the percentages integrated over all this project, that is really what tells you who is going to win this race, not these numbers which move a lot. And so with this number, right, the final calculation that I do here is what does it mean for how much vote you buy? If the fungible token is at $2.3, then due to this number 2.8 here, it means that if you buy one sKAITO, then you get 8.7 votes for your project at the current values. And if you buy one NFT for 5,700, then multiplying these together, you get, in this case for these numbers, you will get roughly 22,000. And this 8 versus 22, this is how these numbers come about, right? So this now explains where these numbers come from. Because I'm not sure about if they count the voted or the staked ones, and I'm not sure about actually the perfect numbers here, what the market cap is, right? Depending on what you actually count there. I am not 100% sure why my numbers didn't work out perfectly, right? So my numbers are a little bit more biased towards sKAITO than the NFT. But nonetheless, I'm just following the formulas. I don't know what they count as staked, and how if this market cap is really just this number times the current price, which I saw on OpenSea. And I also don't know, it might be that they have some delay with the price action, right? If the sKAITO token crashes in price and they don't update this here live, then it might also be a little bit off. But nonetheless, this is where you get these numbers from, right? So one higher one-digit numbers or lower two-digit number for the fungible token, and 5-digit number for the NFT. Finally, I want to say, this ratio, the number of votes you buy per dollar, you have here the formula, right? The voting power on X divided by the market caps. Let's go like this. The market caps, of course, are just the current price of the different token times whatever is actually staked there. You have seen that the market cap of the fungible one is higher, by almost a factor of 10 than the non-fungible one. So this is approximately just how many votes are out there on just from yapping, divided by the price, divided by how much is staked. And all of this change, right? So maybe actually the least changing number here is actually the price, although this is also going up and down 30% for this token sometimes. So there's basically three variables that are constantly changing, that go into how many votes per dollar you buy, which makes then this number basically not, you cannot calculate with it much. It goes up and down. And I think this stake number is also very complicated to get a hold on, because they have this these 7-day blocks and 3 times a week evaluations. But in any case, so this is the math behind this this model. I found it quite interesting. Let me know if you got some more interest in that. I'm really also interested. I would really love to see how they actually do the evaluation. It seems, I mean, people say you just have to talk positively about stuff, but I also saw people complaining that sometimes they get something and then it stops. And I've also made this experience, so it's interesting. I would like to know like how high end their semantic evaluation really is. In the coolest case, it's very good, but you know, maybe because they don't show it, we don't know. In any case, I found this interesting. I would really love to the people who designed this, what the thoughts behind it were. I found it interesting to make this, same bang for your buck normalization. I mean, it's not complicated, right? There's no non-linearity in the sense there, apart from dividing by a number. But it's interesting, and I would love to talk to these people. If you know them, send them my way, show them the video. I would do an interview on just the math and the implementation and the machine learning and the network graph stuff. I would love to talk about this more. Okay, with that said, let's leave it at that. Have a good day.